Now we're going to talk about something very new, which is radians. If you remember, when we're using the calculator, it actually defaults to radians because in higher level math, especially pre-cal and calculus, you'll see that unit instead of what we normally use to measure angles, which are degrees. So what is a radian? First of all, I'd like you to start by imagining an equilateral triangle that I made from the radius, which I've drawn here. What would the measure of length A be? Well, it'd be 60 degrees. Okay, now what if I took that side here, BC, and I stretched it out and I let point C slide so that this would completely line up with the edge of the circle instead of being a normal straight segment? What would happen to angle A? Well, let me show you. Basically, let me start from the beginning. Here's my circle with the equilateral triangle here. And if I go ahead and do that arc, this is C after I stretch it out. You can see this leg comes in just a teensy bit. It's still congruent, and you'll notice the angle's not quite 60 degrees anymore. It's 57.29 and then some. So what is this exactly? This is 1 radian. When this angle is 1 radian when the arc length is 1 radius. So basically we're saying the angle is 1 radian because the arc length is 1 radius. So the question is, how many radii can we wrap around a circle? I'm trying to set up a relationship between degrees and radians. Well, I know I can wrap 2 pi r is a distance all around the circle. Well, if each r is 1 radius, that means I can put 2 pi of them there. So every circumference is made up of 2 pi radii. So a circle also has 2 pi radians. I can fit in 2 pi of this angle in here. Now, radians are normally expressed in the number of pi. That's the exact answer. And you can use the arc length formula pretty much the same way. The only thing that changes, you still have 2 pi r's the whole for length, because that's the distance around the circle. But instead of having a total of 360 degrees, you're going to have 2 pi radians. The cool thing you'll notice here is that means that, let me go back to that. I could actually simplify that 2 pi. So let me show you what the cool thing that happens here. These 2 pi's simplify. So I can just say the arc length over the radius, that's the radians. So that gives me the angle. And that's part of the reason we like this relationship. Why we like to use radians is it becomes a lot simpler. We get rid of some irrational numbers, namely pi.
In this example, we're going to look at the radius of a circle. We know the radius of a circle is 7 inches, and we're going to determine the length of the arc intercepted by an angle with a measure of 1.5 radians. So first of all, if we look at the formula that I had on the previous slide, if you struck out the 2 pi on both sides, you end up with arc length over radius equals radians. Now, the way I used this in college, we would actually cross multiply this, put 1 under the radians, and I would get arc length is radius times the number of radians. So then I get arc length is, the radius is 7, it's 1.5 radians, or basically 10.5 inches.
So what is special about the arc length of 1 radian? Hopefully you notice that it is 1 radius.